Alright, what we want to do today is we want to try to expand our current dictionary of our understanding in logic. So what do we know so far? We understand that there are symbols we can use and we can assign any meaning we want to them. We also understand that there are different ways in which we can combine these symbols to form new meanings or new statements. What am I talking about? I'm talking about the and the or statements that are here and here. These are the two different ways that we know so far. Now, for this video, I'm going to introduce a third way in which we can combine two different symbols together. And this one is denoted with this arrow sign. So what does this mean? This means and, this means or, this one means if then. So what do I exactly mean by that? This whole statement over here means if A happens, then B also happens. So let's illustrate this with an example. That's going to help a lot. So what we're going to do, we're going to assign A a meaning and we're going to assign B a meaning as well. We're going to let A be I go to the store, and B is I'll get some milk. So what would this statement mean overall if we have these meanings assigned? Well, taken together, this one would mean if I go to the store, then I'll get some milk. Alright, cool. So that's the third way of combining two different symbols together. Except we're not quite done. The thing is, we still don't really know how this all fits in a truth table. So what do I mean by that? Let's draw a truth table, A and B. So we've done this many times before. The four possible universes are these guys. And if we have our new statement over here, which features our new symbol, how do we know what are the correct entries to fill up over here? Now, this question is quite difficult to answer, and we're going to try to do things one by one, okay? We're going to try to do things entry by entry. We're going to start with the first entry, and let's try to argue our way out of this one. We're going to use something that we learned in our second video, second lecture or something like that, the one on what makes an argument good. So in that video, I stated that if an argument is good, then truthful propositions or evidences lead to truthful conclusions. So how are we supposed to use this fact to fill this entry up? Okay, so the idea is let's construct an argument that is good. So what do we need for an argument? We need to have our evidences and our propositions, and we also need to have conclusions. So let's have two propositions and one conclusion. And our first proposition is this guy over here. And our second proposition is this guy over here. So let's translate that, shall we? So what does the first proposition tell us? The first proposition tells us, if I go to the store, then I'll get some milk. The second proposition is, I went to the store. So what do you do as a detective? What can you conclude out of this? So if I go to the store, then I'll get some milk. I went to the store, therefore I am gonna go get some milk. That's the answer. And I'm sure 100% of you got that right. It's not too difficult. And I'm pretty sure that all of you will agree that this is a valid argument. This is a good argument, a flawless one. So there we have it. This is our argument and it is a good one. What does that mean? That means that we have truthful propositions and truthful conclusions. So, okay, this means that this guy over here should be true, this guy over here should be true, and this guy over here should be true. So, how should we fill this guy up? Well, just put a true over here. And then everything just works out well. The truth of our propositions, this guy and this guy, you see both of them are true. It implies the truth of our conclusion, B. So, yeah, it checks out. Our argument is indeed valid. The next entry we will tackle together is the third entry over here. I'm going to try to argue with a proof by contradiction. So what I'll do is I'll fill in the answer, but I'll intentionally put the wrong one inside. And what I'll do after that is I'll show that a logical paradox arises when I do this. So T over here, keep in mind this is the wrong answer. Alright, so what's the paradox? Why is this not possible? Well, what does this tell us? It tells us that a universe exists. Universe number 3 over here exists. What's the problem with this universe? Well, let's walk through it one by one. Okay, so in this universe, if I go to the store, then I'll get some milk. Alright? And I went to the store. That's true. Statement A is true. But the problem is, I didn't end up getting any milk at all. Now, how could that be? This guy over here is true. If I go to the store, then I'll go get some milk. And I definitely went to the store. This guy over here is true. But how come I didn't get any milk? So that's a paradox. This universe doesn't coexist with logic. It breaks logic. It defies logic. It's not supposed to exist. Therefore, something wrong happens when I place T as the third entry over here. And since T is the incorrect entry, therefore we are only left with one option, and that is F. So that's the only one that we're left with, which means it must be the correct answer. Alright. So these last two entries are a bit more difficult to deal with. So for this one, what I'll do is I will fill those two entries up with the correct answer. And what we'll do is we'll try to change the answers up. And we're going to show that a logical paradox arises, just like before. And that's going to show that the original answer is supposed to be the one that's correct. Okay, so the correct answer here is true, true. Okay, so this is the correct answer, and we don't know why yet, and that's what we'll try to figure out. So we'll do that by showing that all the other options are incorrect. So what's wrong? What happens if this one is false? Why can't this be false? Why? And to answer that, I want you to notice something between this column and this column. What are they? They are exactly the same with each other. What does this mean? This means that they're equivalent, and this means that they convey the same meaning. Now clearly, this statement is not equal to this statement. If you walk into a room and someone says, if I go to the store, then I'll get some milk, and another person tells you, I'll get some milk, are they telling you the same meaning? Are they conveying the same meaning? Well, no, clearly this sentence is completely different from this sentence. They don't convey the same meaning at all. One of them is an if statement, and B is like I'll actually get some milk. Well, like, yeah, I hope I don't have to explain this, but it is 100% clear that this doesn't have the same meaning as this. So, yeah, something is wrong, okay? Something is wrong when we replace a T with an F. We're not supposed to do that, so let's switch it back. Okay, so just something incorrect happens. We don't really want that. What about the fourth one? What if we change the fourth one? What if we change this to an F? Why is this wrong? Well, we have to use the theory of good arguments again. So, yeah. The idea is construct an argument from this truth table. So, my argument will contain two propositions and one conclusion. And the proposition that I'll use is this guy, and this guy, and this guy is our conclusion. Now, take note that this is different from the previous example that we showed. In our previous example on the argument, this guy and this guy was flipped. So they're not the exact same thing. You did not like step into a time machine, okay? These are different examples. So, what do I want to show? Oh, yes. Okay, so the thing is, according to this truth table, this argument is supposed to be valid and correct. But the thing is, it isn't. What does statement 1 say? Statement 1 says, if I go to the store, then I'll get some milk. Statement 2 says that I ended up getting some milk. Alright, what's the problem with that? The problem with that is that those two pieces of information, they can't be used to tell that I actually went to the store at all. Because, you see, there is a possibility that I could have gotten the milk through other methods. I could have stolen a cow from a farm somewhere and milked the cow myself. I could have gotten a milk carton from a relative that came by, or I could have just stole one from my neighbor or something else. I could have gotten it through any other method, and I didn't necessarily have to go to the store. So this argument is not valid. It has holes inside of it. So this is not a valid argument. But according to this truth table, it says that the argument is correct. Why? Because take a look at number 1 and number 2. These are the propositions. The propositions are true, and that led to the conclusion being true. So obviously something is wrong with our truth table. We shouldn't have made this an F. We should have kept it as a T. And why does it fix the truth table when we change it to a truth instead? Well, then our truth table is now valid because, as you can see, truthful propositions should lead to truthful arguments. But now that we have changed this guy with a truth, this argument is no longer valid. Why? Because, you see, my propositions are true, my evidences that I am using are true, but our conclusion ended up to be false. So that's what I'm talking about. I could have gotten some milk if I had went to the store, but I didn't. I got some milk anyway because a relative came by. So this fourth row over here talks about that universe, the universe where a relative came by and gave me milk, so I didn't have to go to the store at all. But that universe is just completely taken away and stripped off when we convert this to an F instead. And then you'll have nasty things like this argument being valid, which it isn't supposed to be when you really think about it. One more thing to note though is, since we can't change this guy and this guy individually, what happens if we change them both at the same time? Would that be a valid change to make? Is there any mistake with that? Well, let's take a look. Now, isn't this thing familiar? Well, yeah, it's supposed to be. This is exactly the same as the truth table for A and B. And surely, this guy is not equal to this guy, because this means A and B both happened at the same time, right? But they could have just coincidentally happened. And so this statement over here isn't necessarily implying that this statement is true. They're not equal to each other. They don't necessarily have the same meaning. I went to the store and I also got some milk. It doesn't mean that I went to the store to go get some milk. I could have went to the store to buy, like, I don't know, chocolate, and I could have gotten the milk from a relative instead. So it's just that these two things happened at the same time. It doesn't necessarily mean that I got the milk from the store. I could have got chocolate from the store, and I could have found the milk on my way home just sitting on the doorstep or something like that. It's just they both coincidentally happen at the same time. You can't say that I went to the store specifically to get milk. Like, that's just not it. So these two things are not the same to each other, although they might seem like the same thing at first. So yeah, this is also out of the possibility, meaning that we can't change both of them at the same time, and we're still stuck with these two being truth. So all the other options, I've covered all of the other options, they're all incorrect in some way or another, and this leaves the final option. TTFT. This is the correct and objective way of writing an if-then statement in terms of a logic table.